Hello everyone, my name is Festum. Today I'll show you how to perform trend analysis in RStudio, especially using modified MK package. But in order to use this modified MK package, first we need to check whether there is significant autocorrelation in our time series or not. Not only for this package, for any package before doing any trend analysis, first we need to check that whether there is significant autocorrelation in the time step or not. If there is significant autocorrelation, we need to perform the pre-whitening procedure, and if there is no significant autocorrelation in the time steps, we don't need to do any pre-whitening procedure. Simply we can jump to the trend analysis. So today, first I'll show you how to identify significant autocorrelation in time series using Excel and R. So first let me show you how to identify significant autocorrelation in Excel. Then I'll show you in R. So let me open my data set. This is my data set. So in my data set I have monthly data plus seasonal data and annual. So in order to perform in order to identify the significant autocorrelation in the time steps, click here and type equal sign, then type CORREL. This is the function for calculating autocorrelation coefficient in Excel. Double click here, then let me calculate the autocorrelation coefficient for the first month. Select all the observations, then comma, then start from the second observation and add one more row here, then close the bracket. Now we are calculating the autocorrelation coefficient for lag 1, then hit enter. So let me do the same thing again. Let me do it here, put equal sign, then correlation, double click, select all the observations, then comma, then start from the second observation and add one more row here. Now we are calculating the autocorrelation coefficient for lag 1, then hit enter. So this is the autocorrelation coefficient for the first month, and if you want to get for all, simply drag this one. This is the autocorrelation for every time scale. So we have the autocorrelation coefficient for every time step. So if you give it number 1, 2, 3, you'll get the autocorrelation for 17 columns, because we have 7 columns here. So we have the autocorrelation coefficient for each time scale. Then the second thing we need to do in order to identify the significant autocorrelation, we have to calculate the lower limit and the upper limit of the interval. This is the lower limit of the interval and this is the upper limit of the interval. If the autocorrelation coefficient is between this interval, we can say that there is no significant autocorrelation in the time series, and if this R, the autocorrelation coefficient, is outside of this interval, we can say that there is significant autocorrelation in the time step. So first let me calculate the lower limit. Type equal sign minus 1 minus 1.645 times n minus 2. N is number of observations. So if you see the number of observations here, our observation starts from 1985 and in 2012. So we have 28 years here. So n is 28. So 28 minus 2 is, open bracket first, 28 minus 2, it will be 26. Then close the bracket, then use power sign, shift and 6, you'll get the power sign, then 0.5 5, then close the bracket, and divide by n minus 1, or n is 28, 28 minus 1, 27, then hit it. So accept the correction. Sorry, there is some error here. No times, it is divided by n minus 1, or n minus 1 is 28 minus 1, it will be 27. Hit enter. So this is the lower limit. So in order to calculate the upper limit, simply copy this one and paste it here, then double click here, and if you see the difference between the lower limit and the upper limit, we have minus here and we have plus here. So come here and replace minus with plus, so you'll get the upper limit. Hit enter. So this is the upper limit and this is the lower limit. The upper limits and the lower limits for all time scales are the same, so simply drag this one. So as I've told you before, in order to say there is significant autocorrelation in the time steps, we need to have autocorrelation coefficient which is outside of this interval. So let me show you how to compare the autocorrelation coefficient with the values with the interval. So use type equal sign, then use if function, conditional function, double click. If this value is greater than or equal to the lower limit, comma, type no significant autocorrelation, comma, if the autocorrelation coefficient is less than or equal to the upper limit, type no autocorrelation, comma, if the autocorrelation coefficient is less than or equal to the lower limit, type there is significant autocorrelation if it is outside, comma, if the autocorrelation coefficient is greater than or equal to the upper limit, type there is significant autocorrelation, then add 1, 2, 3, 4, hit enter. So there is some error. Let me fix that error. No. Sorry, we need to add quote here. Quote. And come here and hit enter. Okay, in order to get for all, simply drag this one. I think there is some problem. Let me fix that problem. Double click here. Let me forget this one and write it as interval. Let me write it as interval. Lower limit less than or equal to the correlation coefficient less than or equal to the upper limit. Name it. There is no autocorrelation. Let me write false. And if the autocorrelation coefficient is outside of the interval, let me write true. True is there is significant autocorrelation, and false is no significant autocorrelation. So subtract 1 bracket. Let me check, comma, If it is between, type false, and if it is outside, type true. Then hit enter. So the first one is false, then drag in order to get for all. So we have false here, we have false here, we have false. This one is also false. There is no significant autocorrelation in this time step. So for this time scales, we cannot use the modified MK package for this one as well, and for this one. But for the remainings, we can use the modified MK package because there is significant autocorrelation in the time series. So you can check whether there is significant autocorrelation in the time series using Excel sheets by doing the same step. Let me show you the same procedure, the same analysis using R. So minimize this one and open R. This is my RStudio. Then let me bring my data sets, desktop. This is my data set, which is the same data set with the previous one. Import it. Then after importing, let me assign vector variable for each time scale. How can you assign vector value? Type x1, assign station name at this, type $sign. Then x1 is for January, hit enter. We have assigned x1 for January. Copy this one, paste it here. x2 for Feb, type the same name, Feb, hit enter. Paste x3, March, hit enter. I'm not going to type for all. I'm not going to give assign vector variable for all. I only show you some of them. Type x4 for April, then hit enter. So now we have assigned vector variables for the first 4 months. Then after assigning, in order to check whether there is significant correlation in the time step, type ACF, then enter. Then in order to check for January, type x1, comma, lag box maximum. We are going to calculate the correlation for lag 1 as we did for the Excel. Hit enter. So if you see here, we have a graph. So if you zoom the graph, you will see that the autocorrelation coefficient at lag 1 is between the interval. So if it is between the interval, so we don't have significant autocorrelation in this time step. We can cross check with the Excel one. So in the first month, we don't have significant autocorrelation. And if you want to check the autocorrelation coefficient here, type, copy this one, paste it, and add $sign plus ACF. Hit enter. So this is the autocorrelation coefficient. If you see it here, they are the same. They are not completely the same, but there are some minor difference. So for x2, paste here, replace x2, hit enter, then zoom the graph. Even for the x2, our autocorrelation coefficient at lag 1 is between the intervals, so there is no significant autocorrelation. Then in order to calculate the autocorrelation coefficient, ACF builder. So this is the autocorrelation coefficient. You can see they have relatively the same value. For the, let me jump to the fourth time step because there is significant autocorrelation. Type, let me replace this x2 with x4, then hit enter, then zoom it. So if you see the autocorrelation coefficient at lag 1, the autocorrelation coefficient is greater than the upper limit, which means it is outside of this interval. So from this we can say that there is significant autocorrelation in this time step. So the same here, it is true. We have significant autocorrelation. So you can identify the autocorrelation, significant autocorrelation coefficient, significant autocorrelation in time step by doing the same using R and then using Excel. But our main objective is we are going to perform trend analysis in RStudio using modified MK package. But before using the modified MK package, we need to check whether we have significant autocorrelation in our time series or not. So we did the same. So come here, package. Before that, let me show you how to install modified MK package. Type install.package parenthesis, then modified MK, then hit enter. You can install the modified MK package in RStudio. Then after doing that, download the file for the modified MK package. Let me show you the file, the PDF file. This is the PDF file for the modified MK package. So in the modified MK package, we have different functions in order to perform the trend analysis. In my case, I prefer to use this function, which is in page 5. Let me show you. Page 5, which is BCPW. Why I prefer to use this function? Because the lag 1 serial correlation coefficient is corrected before pre-whitening procedure. So the bias will be corrected before doing the pre-whitening procedure. That's why I prefer to use this function. So I have already installed the modified MK package in my RStudio. Then come here, type modified MK. So this is the modified MK package activated. So as I told you before, we use this modified MK package only for the time scale which has significant autocorrelation. Okay, so as you see from here, the fourth month, which is the April, has significant autocorrelation. So we can analyze the trend analysis using the modified MK package. So we have assigned value for April, which is x4. So in order to analyze the trend, type, as I have told you before, we are going to use this function BCPW, then x4 for April, then hit enter. So this is the result for the trend analysis. This is the Z value, which is greater than 1.96. This is the sin slope, and this is the p value. If you see the p value, it is less than 0.05. and the z value is greater than 1.96. So from this we can say that there is significant increasing trend. This is our variance. This is the old sine slope. I think this is the old sine slope, and this is the new sine slope after pre-whitening. So you can do the same for all time scales which have significant autocorrelation in their time series. So thank you for listening. If you like this video, please subscribe my channel. Bye.